They want us to solve this inequality, and keep in mind that your inequality is this symbol right here, and this one is the greater than or equal to sign. But we're trying to figure out what value of x that when we multiply it by 9 and add it to 15 on the left side will give you a number greater than if you take that number times 4 and subtract 10 on the right side. So I have to solve this, and right now I've got x's on both sides of the equation. You want all the x's on one side. Now it doesn't matter which side, but when you're dealing with inequalities, it does make more sense to get it on the left side. So I am going to subtract 4x from both sides so that it cancels out there. That's going to leave me with, when I do this part right here, 9x minus 4x is 5x. Then I still have the plus 15. I still have the greater than or equal to. But when you take 4x minus 4x, that's basically 0. And 0 minus 10 is a negative 10. And now I want to get rid of this 15. So you're solving for x. You've got 5x plus 15. You just want the x. So get rid of the 15 next. I'm going to subtract 15. That cancels out to be 0. But when you're solving equations, you have to abide by that law that says what you do to one side of an equation, you got to do to the other. So don't forget that. And that leaves me with just the 5x on the left side, because this part canceled out. It's gone. It's 0. And 5x and 0 is 5x. Is greater than or equal to negative 10 minus 15 is a negative 25. And then my last step is to get rid of the 5. Now this 5 is multiplied onto x, so to undo that I would turn around and divide. And what you do to one side, you got to do to the other. 5 divided by 5 is really a 1x, but 1 times x is just x. So you get x is greater than or equal to negative 25 divided by 5 is a negative 5. Now, Mobius says enter the exact answer, and they want it in interval notation. Now I have x is greater than or equal to negative 5 as an inequality. That's not what Mobius wants. Also, I am a visual learner, so for me it actually helps to graph this. Like, here's a number line. If this is negative 5, down here is negative 6, up here is negative 4, you know, way down here is 0, right? If I were to highlight all x's that are greater than or equal to negative 5, I'd start at the negative 5, and I'd highlight in the direction to the right. Now, that's one way to do it. Another way to do it is to put a bracket right here on the negative 5. And go this way. Some textbooks use a solid dot, others use the bracket, but in order to put it in interval notation, I need the bracket, because the equal to part right here says include the negative 5 with your answer. A solid dot or a bracket tells me that. So I use the bracket, I put negative 5, I go comma. That's where our x's start. For an interval, we need to know where they end. Now, they keep going to the right, and that's what these arrows imply. Technically, eventually, you would hit infinity down there somewhere. Okay? So any number that is greater than or equal to negative 5 would be a solution. And if you wanted to check that, I don't know, pick something greater than negative 5. 0. 0 is the easiest number to work with right here. So if I were to plug a 0 in here and a 0 in there, 9 times 0 is 0, and 0 plus 15 is 15. Is that greater than or equal to 4 times 0 is 0, and 0 minus 10 is a negative 10? Yes, it is. I have got the correct answer. Now, when you go to Mobius, it says to enter infinity, type the word infinity. So I'm just going to jump back here to Mobius. Oops, your session has expired. No. Okay, I'm still in there. And I would type in bracket -5, comma, and then just type INFINITY and close a parenthesis. I don't think you want to hit any spaces. And then I'm going to check the how to do. And yay! It turned into a green, it circled it in green or enclosed it in a green rectangle. And you'll see a little check mark, and it does say you got the correct answer. And then once I do that, if I do get the correct answer, it actually shows me how they solved it. I solved it a little bit. I divided both sides by 5, where they multiplied by 1/5. That's the same thing. But anyway, that is participation activity number 3.